All right, so let's go ahead and start. Let's recenter our focus on this so we can start talking. So, we've got a table here. Today we're going to be focusing on tables, right? 5.1 we focused on graphs. Today we're going to talk about tables, and tomorrow we're going to talk about situations, which is essentially word problems. So it'll be fun. But today we're just dealing with tables. It's nice and easy. We're going to use exactly what we already know about finding slope from a table to find our slope here. And we're going to have to actually write the whole linear equation of this line. Now, what's something different about this table that you notice compared to the tables we've been working with before? Anything jump out to you? Is there something missing on this table by any chance? Hannah? Yeah, there's no x value of 0, right? So this table doesn't show us right away what our y-intercept is. We can't just find where x is 0, take that y value, and say, boom, that's my b. So we'll get to that in a second. First, let's figure out, is this even linear? And to do that, we're going to try and find the slope. So we're going to find the change in x, and we're going to find our change in y from our table. So after the question, is it linear, I added this note, find the slope. And then I put a note down here, find change in x and the change in y from our table. If we're going to find the change in x up here, what are we going to have to draw above our numbers? Does anyone remember how we find the little change in x? Noah?
You see how much it is to get to that number.
Exactly. So what's the little thing we draw on top of the boxes? Yeah, a little bump with an arrow, right?
Yeah.
So when we're finding the change in x and the change in y, we're just doing this little arrow over from point to point. What's our change in x from the first 2 points?
1.
Plus 1, right? What about from 2 to 3? Plus 1, and from 3 to 4? Plus 1. Okay? Then we go down to y. How do we get from 22 over to 24? Plus 2. Then we got plus 2 and plus 2.
Yeah.
On the bottom is our change in y. On the top is our change in x. So we're going to go ahead and find the slope first. We're also going to have to find the y-intercept, but let's just find the slope first, since we already did all the work for it, right? How can we set up this fraction here for slope? What number is going to be in our numerator? Azalea? 2. And what number is going to be in our denominator? 1, right? That simplifies to just 2. So we've got a slope of 2, that's nice. Let's go ahead and do the second thing, which is finding the b. So what is our b? Oh, it's crooked. There you go. Now there's two different ways we can go about doing this. we can just do what we've been doing, right? We have a slope, and we've got multiple different points that we can use. So the first thing we can do is plug in our slope and just pick a point off the table and plug it into b equals y minus x. So let's see that one first. There's two options. Here's option one. I'm going to move this up a bit. So option one is use b equals y minus mx. And any point from the table. The second option we can do is we can fill in our table. If we want to go for the not so mathematical approach, we can fill in our table until we find a point where x is equal to 0. Most of the time, you'll be able to do both options equally as well. Depending on the table, though, option 2 may take a little bit longer. Just depends. So let's go ahead and see what option 1 is going to look like. Sorry, we're going to take the point. Well, we know that our slope is equal to 2. And we're going to use the point 1, 22. B equals y minus mx. X is 1. Y is 22. So we could write this as B is equal to 22 minus 2 times 1. Two times 1 gives us 2, and 22 minus 2 equals what? 20, right? So with our first option, we found that our b is equal to 20. It wasn't too bad, right? We just picked any point off the table. If we had done 24, 2, we would have gotten the same exact answer. Doesn't matter which point you take. I would just take the easiest one. And then here's the second option that we have. Let's go ahead and we're going to redraw our table, but I want you to leave the left side of your table open, like that. Okay, so don't draw a little wall on the left side of your table. Keep it open. Fill in all your numbers again. 26, 28. 1, 2, 3, 4. So keep in mind, a table isn't all of the points on that line. It's just a little screenshot of a couple different points on that line. In reality, there's an infinite number of points on an infinite number of lines, right? So we're just taking a look at four points that we were able to identify on this line. But we could fill out the table more to the right, and we could fill the table out more to the left. In both directions, forever, we could do that. Luckily for us, we don't need to go very far. So we're going to fill in our table until we find a point where x is equal to 0. So do you think that's going to come to the right of our given information or to the left on our table? To the left, right? We see that an x value of 0 is going to come right before this x value of 1 because our change in x we know is plus 1, right? So we can backtrack a little bit and actually subtract 1, going the opposite direction, if you guys see what I'm saying. So if we subtract 1 from 1, we get 0. Now whatever we do to the top, we have to do the same thing down to the bottom proportionally. Down here, our change in y is plus 2. So if we're going to go backwards one step, what would our y value here be? It would be 20. We got to subtract 2, going the opposite way, and we get 20. Now look at this table. Does that look like it's proportionally accurate, right? Adding in this additional point? Absolutely. Absolutely. So from this table, we can then assume that b is equal to 20. Because our y-intercept is at the point 0, 20. Is that the same b value we got from doing option 1? Yeah, it sure is. Now, which one is easier for you is up to you. Like I said, 99% of the time, you're going to be able to use them interchangeably. Let's do another example. I'll leave it right there. Yeah. Okay. Do you need to see the nurse? Okay. Here you go, sir. Tip. All right. Let's do example A. Go ahead and copy down this box of points right here. All right. There's your table for example A. All right. I'll give you guys a couple seconds to get that copied down. Okay, so we got our table here. First thing we want to do, get it out of the way. Let's find our slope. What's our change in x up here on the top from 6 to 8? Plus 2, right? What about from 8 to 10? Plus 2. What about from 10 to 12? Plus 2. Nice and constant up on the top. How do we get from negative 3 to negative 6, though? Minus 3. From negative 6 to negative 9, minus 3 again, and minus 3 again. All right? So we know our slope is equal to change in y over change in x. It's going to be equal to negative 3 over positive 2. Can we simplify that at all? No, we're going to leave it just like that. Negative 3 over positive 2. Okay, so we got our slope. Let's go ahead and find the y-intercept. Now, we could use either option 1 or option 2 here. It doesn't matter. I want to show you guys option 2. So again, make another little box that's got an open side on the left. 1, 2, 3, 4. 5. Let's go with that. So, we're going to fill in the left side of this table here until we hit an x value of 0. So how many spaces in our x row do we have to go back? Well, we're plus 2ing every time, right? So what number would come before 6? 4, right? Now you can either do the minus 2 backwards. I just do the plus 2 forwards. It all depends on how you like to think about it. It's the same either way. You know you're going to go 2 forward, 2 back. What comes before 4? 2. And what comes before 2? Bingo. That's right what we're looking for is right there. Now we just have to backtrack the y-axis. So what's going to come right before negative 3 if we're subtracting 3 each time? 0. That's right. Let's go ahead and I'll write plus 3 in the other direction. We're going to get 3. And then we're going to get 6. So what is our value for b here? 6. Exactly. We're looking for this box right here. Anytime we see an x value of 0, whatever number is next to it, or below it I should say, that's our y-intercept. Because if you plot the point 0, 6, or 0, 2, 0, 3, that dot's going to land right on the y-axis. Jordan? Yeah, go ahead. What's that? I see what you're saying. Go ahead. All right, we got our m, we got our b. Can we write an equation now? Yeah, what's our equation going to look like? That's right. We're going to have y equals negative 3 over 2 x plus 6. That's right. So we took our slope, doing the exact same thing as normal, change in y over change in x. We're pros at that by now. And then we just worked the table backwards. Now, yes, we could have also taken this slope, negative 3 over 2, and one of these points, 6 and negative 3. But just so we can see that, right, we'd have b equals y minus mx. Well, if we take the first point, y is negative 3 minus negative 3 over 2 times 6. Negative 3 over 2 times 6 would be negative 9. 6 times 3 is 18. Divided by 2 gives us 9. Negative 3 minus negative 9 becomes negative 3 plus 9, which is equal to what? Positive 6, right? We got the same b value either way, whether we did option 1 or option 2. I'm letting you decide whatever you're more comfortable doing. Some people like working out like this, just like we were doing yesterday with Matho. Some people like to visualize the table better. Again, it's up to you. I don't care which one you do. They're both fine. All right? Questions about this? Cool. Okay, what I want you guys to do real quick, go and get your Chromebooks out for me.